Hello everyone, and thank you for tuning in again. Today I want to show you something very interesting, how you can get use of those little modules here, manufactured by the company FTDI. This is originally a USB to serial converter, so you can establish a virtual COM port, but this is nothing special. But those devices also support some different bit modes, so you can use this actually as something like a parallel COM port device. You can read out and set data parallel by reconfiguring this device from serial port to parallel input-output port. And you actually can do this by using a cool library FTDI provides in the programming language Purebasic. I'm using since some years, and I've been tinkering around with Purebasic for a while, and really is great. And I want to show you how this works. But before we start, I show you my application. So first let me say that this whole application here, the Purebasic IDE, is running in Linux on my system. This is somehow challenging because a lot of things, also binding in an external library, is a little bit easier when you're dealing with a Windows environment. But I made it and it really works great, and I want to show you this in this tutorial. So this is my breadboard here. You can see I soldered this little FTDI device I bought from Amazon here on this breadboard, and I soldered 3 green diodes here connected via these 1 kilo ohm resistors to some inputs here on the FTDI board, and also switch. You can see we have a little key here we can press, and it makes it gives a voltage here on some other pins of the input. So, because I just want to show you the principles here, I don't provide here any schematic, because which pins you want to use is not of any interest. This is your decision what configuration you want to take. Okay. And this is my Purebasic IDE, so I'm going to start the program here. So this is my Bitbang demonstrator, and I will see if I can place this breadboard here in parallel so you can see both. If I, oh no, let's take a look here at this editor window here. You can see that the FTDI device was found, it was connected, async bit mode was established, and baud rate was set to 9300. The async bit mode is what I told you before, is the bit mode you can establish here when you want to use this model here as a parallel input-output device. So if I now click here, hope you can see it. It's not too dark. Yes, I can see it. LED 1, then the first LED here from the right side is illuminated, and when I click again it's off. We can do the same with the second and with the third LED. So these are toggle buttons here. And you can see those green fields here. When I press the key here on the board, you can see it actually turns to red. Green, red, green, red, green, red. So it's really easy to make something like remote control applications here. You can apply an transistor, additional transistor, and you can switch a relay. And with the relay you can switch some desktop lamps or anything you want here. And you also can get in some data, for example for sensors, or let's say door switches for establishing a burglar alarm or something like that. So the ideas are endless. And now I want to show you the principles of my program and the preparations I have had to do to keep it running. Okay, so start your browser and then go to www.ftdichip.com/driver/d2xx.htm. This is the site from FTDiChip where they're providing the download of the D2XX drivers. You have to know that for those FTDI devices there are two different let's say driver models existing. The most common is the VCP, the Visual Compound Driver, which does nothing more than establishing a USB to serial port emulation. This is the normal use case for those devices when you want to realize a COM port with the FTDI. But there's another driver model existing, the D2XX drivers, and those drivers have the additional functionality of establishing the different other modes, for example like the Bitbang mode that turns your serial COM port into a parallel input-output port. This is what we're going to do. So you have to use this page here. Because we're using Linux, we have to download this driver here, the 1.4.6 driver. This is the actual version, 46-bit. This is 64 bits. I already downloaded it, so I won't do this for now. Here you have it, the Linux driver installation guide. You have to go to the install guides section and then you get the Linux driver installation guide, and this tells you everything I want to show you now here in the video is regarding the installation of the driver is written here. Okay, and what's also very interesting for programming is when you download this one here, the D2XX Programmer's Guide. This is an excellent documentation that describes every function available in the library with all these input-output variables and also the constants, the enumerations, and some examples. It's really worth reading it. Okay, now as we downloaded everything, we now have this file here. It's a zipped tarball, and we unzip it by doing unpack. So as you can see here, when you open the release directory, we have a readme note here, and it's a good idea to take a look into it with your favorite editor. Now everything that is necessary to be done to install this library is stated here. We only use the shared library because we will not recompile the whole program with the static library added to it. We will use the shared library during runtime. So we have not to do everything that is written here. So let's open the console. And as you can see here, we have to go into the build directory of our downloaded file. So let's go over to downloads. Let's see where we are. Okay, we go into release and then we dive into build. Okay, the first thing we have to do is to copy those files that are related to the dynamic library over to the file path user local lib. So let's do this first. Sudo copy. In this case, we essentially don't need sudo because user local lib is a private directory for the respective user, but I'm accommodated to use sudo when I do copying files that are related to be used by anyone on the system. So we say lib FT232 dot wildcard over to user local lib. We have to apply the password. Okay, and it's done. Now we need to change the attributes of the shared library, so we can get access from every. We can grant access for every user on the system. This is done by change mode. We have to use sudo change mode 0755. These are the attribute bytes. User local lib and lib ftd2xx.so, not 0, type an O. Don't make the mistakes I already done. So I think that's it. Oh, it doesn't work. I have a typo here. Lob is not lib. So let's see if this works now. Okay. So now let's check this. Go over to user local lib. So here we have our shared library. We had read, write, execute rights for the owner, read and execute for the group, and read and execute for everyone else. Okay, so the last thing to do is, because every time this library here changes when it gets a new version from the FTDI guys, that is a problem, because this library is addressed from your program, from a Purebasic program, and when the name changes due to the version, you always have to correct the path in your software. So for this reason, we will follow this advice here, and we're gonna apply a soft link. This is done like this. This implements a soft link, and we apply the full path user local lib, and then this much too complicated name for me, lib ftd2xx.so.r146. Yeah. And the name of the link is user local lib ftd2xx.so, and of course we should use sudo. So let's see if this string of madness performs well. Yes, you can see it here. Okay, so now we copied the library to the right repository, and we applied a soft link. So now we can go on to do something with the software. Okay, I already started Purebasic. Something very important I have to say previously, before we dive into this matter more deeply. What really is important, to start the IDE in super user mode, in admin mode, because if you don't do so, you're running into serious trouble, because
we don't have a consistent chain of writes for all those programs, starting from the IDE and ending on the granted rights of the library and its connection to the outside with the USB bus when you're not in super user mode. And also, as far as I'm concerned, I found out that the IDE itself doesn't work very well if you're not in super user mode. So when I start Purebasic, I always do sudo and launch, so I'm in super user mode. If I don't do so, I get some problems, for example, with the history database and some other issues here in Purebasic. Okay, now after we made this straight, let's dive into the software. This is the code. The code starts by including this Purebasic form, which look like this. There's nothing more to say about this apart from what you can see here. We have those LED buttons which are configured as toggle buttons, as you can see here, because we checked this option here, Purebasic button toggle. This is a string, and this is an image gadget, and this is an editor gadget for taking some messages from the system. So the real interesting part here is in the FTDI show Purebasic main file. So after including this form file, we have some enumerations on, enumeration not the right name. These are in fact constants. So let me fix this now. This is the string length. I'm going to tell you later what this means. Also, the max bytes is nothing we want to deal now with. This is a bit mask we use for putting the FTDI chip, the FT232, in as a bit mode. And the bit mask is something we use together with this as a bit mode in a library function to tell the device which parts or which bits of the data I/O port have to become inputs and which have to become outputs. Here in the commands you can see what the configuration will be like. The lowest bit is the TXD, the original pin description when you use it as a serial I/O device, is an output. Also bit 1 is an output and bit 3 is an output. You can see all these bits configured for output take a 1 in the configuration bit mask. If you want the pin to be an input, you have to apply a 0. So this is something that you're maybe familiar with from the pin configurations in PIC controllers or AVR controllers. It's pretty much the same. Then we have now a real enumeration. This is taken out from the D2XX Programmer's Guide. We have a very nice description of everything that the library functions can return when they did their job. What we always want is FTOK, which is a 0, and all this other stuff here are errors. Okay, then we need some structures. What do we need structures for? Okay, the main problem is when you're dealing with libraries that you are binding into Purebasic is that you can't work with pointers on atomic variables. For example, you can't put a pointer to a long value or an integer value or a float value. Purebasic is not able to handle this. You always have to apply a structure. So these structures here mainly are helper structures. You can see that they normally only contain one field. For example, this double word structure contains a D word, which is a long value in Purebasic. Or the word structure contains just a word. The byte structure contains just a byte. Don't get confused because the type here is an A. A means it's an ASCII byte, is another word for it's an unsigned byte. And you also can see that this is configured as an array here. And now the FTDI max bytes come into play. We specified here. That means we have an array of 20 fields in this byte structure. But we will use only one in our example. Okay, then we have an info node structure. This is something the create device info list library function uses to give you some informations what type of device we are dealing with. And then we have some globals here. You can see we have an FTDI byte of type byte structure. This is actually what we will use to send out data. In this case we will only use 1 byte, but it's actually possible to apply as much as you want into this array, and you can put it out just by one function call all in one piece. That's really cool. I made some SPI related application with this and it works quite well. Then we have a handle. This is nothing more than you maybe know it from file handling. You always have a handle to a file to do something with it. Here we have a file to the device, a handle to the device. And this here FTDI read is, as you can see, an unsigned byte, and we use this for reading in the data from the data port, which in our case is only 1 bit. So now comes the tricky part. When you are using a library in Purebasic, you first have to apply the library path. You can see here we have a path variable which is a string type, and this is the path to the library, or namely to the soft link of the library we implemented. And then we use a function open library which takes this path and gives us back a handle to this library. And here we check if the handle is something else than 0. If this is the case, then we have a valid handle, and we make some prototype definitions. The prototype definition is something very elegant implemented in Purebasic, how you can deal or how you can get access to the functions of a dynamic library. This is by specifying a function as a type. What here really happens is that you are defining a type. In this case it's the type FT_open, and you apply the parameter structure, let's say the footprint of this function, here between those parentheses. Device I is a handle, and here you can see you have a pointer named FT handle of type double word structure. So this is, let's say, our link to or first link to the library function by specifying of what type it is. And then we make global a function named FT_open, which also has the type FT_open, and we use the get function, it's a Purebasic function, to access the specific function FT_open in the library. And here we really must take care. The name FT_open here in put as a string must be exactly the same name, in case sensitive, the same name as it is written in the D2XX programmer's guide. In this document all the names of those functions are listed, and you have to apply exactly the same name. So in this way we go all through all those functions we need. This first function here is to open connection to the first device we have found. This is the function FT create device info list. It gives you back the number of FTDE devices the library found on the USB bus. And set bit mode is what we need to put the device in the async bit mode, as I told you before. Get bit mode, this is really confusing. It's a really bad name, because when you see this you are assuming that by fget bit mode you get back the configuration, the bit mode configuration of the FTDI device. And I really got confused by that, because this is not the case. What you get here with fget bit mode, you get the status of the data input port of the device. So this is really confusing. Okay, then we have FT_write. FT_write is, as the name implies, writing data to the outside. accessing the output port. And you also can see here we have some pointer variables of structure types. And we also have a function that sets the baud rate. The baud rate specifies how fast your information gets visible on the output port. And an FT close function that closes down the connection to the FTDI device. Okay, if opening of the library fails, we have a message request that tells us that something was wrong, which was likely the path of the library. Okay, here you can see the functions, the Purebasic functions I made that using those library functions here, we get access by these structures here. For example, you can see I have a function FTDI open, not FT open, FTDI open. This is my meaning how to coin a term that this is the Purebasic function and not the library function of the FTDI chip. And you can see I use this function FT open, which is this one here. And I apply an index. Index is the index of in the array of found FTDI devices. It starts always with 0. And here you can see a handle. And handle here is a double word structure, and it is applied as a pointer because we put here the address of the handle by this @ sign here. This is the nomenclature of Purebasic to specify this is a pointer. The pointer to this variable here. And when all this is done, when we invoke this function, we have information of the handle here in the data field. Handle, the D word. I show you this one here from the structure, double word structure. This is the data field. And I return this. And I have the same way of following in all those other functions here. For example, the create device info list works the same. We specify a local variable here and we apply it as a pointer to create device info list, and we get back the number of recognized devices on the USB bus. It's the same with the bit mode, where we apply the bit mask and the mode. The mode tells the device to get into async bit mode, while the mask tells the device which pins have to be out and which pins have to be input. So this get bit mode is the function we use for getting data from the port. We're reading the data, and FT close is closing the device. So this is basically all what is to say. The rest here is a very normal Purebase. There's nothing more to say about this. You can see the structure here of these button event handlers is very simple. Every time a button is clicked, we set or reset the respective bit for the LED in this FTDI byte variable, and then it's sent out to the device by the function FTDI write. And this part here of the software is doing the whole connection stuff. It's starting by checking the function FTDI create device info list. When it gets back at least a value of 1 and knows one device was found, then it tries to open it or to connect it. When it's connected, we go to the next part and we try to establish the async bit mode, and finally we're setting the baud rate. Normally you can establish here every baud rate up to I think 156,000 or something like that. Okay, here's our event loop, and in the event loop we have two ways. The one way is to process the window events, which is done here, and the other way the program goes through when no window event is present, and then constantly the FTDI read function is used, or the get bit mode function is used to get the status from the data port and to set the image on the front panel to the respective color in regard of the status of the input pin. Okay, and that's all. So one very important and last point is when we start this now. I already plugged in the device. Let's start this. You can see it does not work. FTDI device was found, but we could not connect it, we could not establish the bit mode, and we could not set the baud rate. And now when I press the button here, nothing happens. So why is it so? Well, this is something special in Linux. Linux has built-in drivers for the FTDI chips, and these are the visual comport, the virtual comport drivers. And it actually, or normally loads those drivers instantly when it recognizes an FTDI device is on the bus. So that means now the wrong driver is loaded and we can't connect it with our dynamic library because we have the wrong driver. So what we must do is we must start the console again, and we have to remove those false visual component drivers. We do this by typing sudo remove mod FTDI _co. Okay, and we do the same, remove mod USB serial. It's the second part of the driver. Okay, and now I hope, let's keep our fingers crossed. Yeah, you see. It found the FTDI device, could connect it, bit mode was established, and baud rate was set. So never forget this. This is a little clumsy in Linux because the drivers are fixed, implemented in the kernel of Linux. You have to remove them. Maybe this can be done by some kind of script automatically or something, I don't know. But I think it's not too hard, it's not too much pain to type in those 2 lines and to remove the wrong driver. Okay folks, that's all. Thanks for watching. I will put this example here in my Google Drive and will give you a link to it so then you can study the source code by yourself. Thanks for watching and bye.